Today I am going to give you a important theorem in probability, that is addition theorem for n events. Here we are having a1, a2 and so on an will be your events. Then we have to prove that probability of union I is equal to 1 to n ai, where it is nothing but probability of a1 union, a2 union and so on still up to an is equals to summation I is equal to 1 to n probability of ai minus double summation where I and j will be lying between 1 to n probability of ai intersection aj still up to minus 1 whole to the power of n minus 1 into probability of a1 intersection a2 still up to an. This will be your first equation. Let it be taking as first equation. We are proving this theorem by using mathematical induction. As mathematical induction is having the first step, we have to prove the given equation, that is first equation, by n is equal to 2. In the place of n, we are going to substitute the value of 2. That means for 2 events it is already proved as it is of addition theorem for 2 events. We are going to write that statement over here. That is probability of a1 union a2 is equals to probability of a1 plus probability of a2 minus probability of a1 intersection a2. Let it be taken as equation 2. That means equation 1 is true for n is equal to 2. Now the next step is of equation 1 is true for n is equals to r. That means you are going to assume that it is true. That is your second step for proving the mathematical induction. Now, probability of, in the place of n, we are going to replace with r. That is probability of union I is equal to 1 to r, ai equals to, wherever you are having n in your first equation, we are going to write r. That let it be taken as equation 3. Moving on towards the next step. We have to prove that equation 1 is true for n is equals to r plus 1. That means probability of, where we are going to take the value of n as r plus 1. That is probability of union I is equal to 1 to r plus 1. ai is equals to probability of union I is equal to 1 to r ai union a r plus 1. That means we are going to split the values of r and still up to r plus 1. We are going to still up to r plus 1 terms. Just wait 1 minute. Now we are going to write that as a union for these two. What will be the value? The union I is equal to 1 to r, ai will be your a and ar plus 1 will be your b. Then we are going to write this as probability of a union b. Here this is of a and this is of b. What is the formula you are having? Probability of a plus probability of b minus probability of a intersection b. In the place of a you are having union I is equal to 1 to r ai, and in the place of b you are having a r plus 1 terms. Just we are going to substitute that. Now what you know from equation 3, probability of union I is equal to 1 to r ai is nothing but summation I is equal to 1 to r probability of ai minus double summation ij will be lying between 1 to r and probability of ai intersection aj and so on, probability minus 1 whole to the power of r minus 1 into probability of a1 intersection a2 and still up to ar. Then what are the remaining two terms? We are going to write those two remaining terms over here. That is plus probability of ar plus 1 minus probability of union I equals to 1 to r ai intersection ar plus 1. So by taking, we are using the equation of 3. Now what we are going to write here? probable, since these two terms are there, that is summation I is equal to 1 to r p of ai and plus p of ar plus 1. We can write this in one single summation, that is summation I is equal to 1 to r plus 1 probability of ai minus double summation ij lying between 1 to r probability of ai intersection aj plus so on. The terms which are you are having here, we are going to write that the remaining two terms, that is this one and this one. Let it be taken as equation 4. See, in this equation 4, you may know about this value and this value and this value, but you don't know about the value of last term, that is probability of union I is equal to 1 to r ai intersection a r plus 1. This you don't know. Let it taken be as consider. We are going to find out this value by taking consideration of that last term. The last term is nothing but probability of union I is equal to 1 to r ai intersection ar plus 1, which is equal to summation I is equal to 1 to r p of ai intersection ar plus 1. Let it be taken as this minus, that means you are going to write ai intersection ar plus 1 as your ai. We are going to consider that value. Here in the place of ai you are going to write that. So what will be the second term? I and j lying between 1 to r. In order to write in the place of ai, that is ai intersection ar plus 1 intersection aj, you are going to write. The last term is will be your ai in a1 intersection a2 intersection and so on intersection ar plus 1 terms. Let it be taken as equation 5. Now substitute whatever you are getting in your equation 5 in equation 4. So the last term is your equation 5 value. We are going to write it in your equation 4. Then what you are going to get? The first term is nothing but probability of ai, where the values are from I is equal to 1 to r plus 1, that is summation. Whatever they are, you are having that I am going to write here, minus double summation probability of ai intersection aj. See, here ai intersection aj and here ai intersection, minus into minus will become plus. So what you are going to write here? Minus double summation, here up to a j values are there and one more value of j will be also there here, that is a intersection aj intersection a r plus 1 terms are there. That's why we are going to write the double summation values are tending from 1 to r plus 1 for ij, probability of a intersection aj and so on. We are going to get in the place of n as r plus 1 terms, that is minus 1 whole to the power of, just here you will be getting the value of r. I am going to add plus 1 and minus 1 over here to get the remaining value. Therefore equation 1 is true for n is equal to r plus 1. Hence proved. Thank you.